Hey guys, so I've been meaning to get this to you. I don't know what happened to my first recording. It either got saved somewhere that I couldn't find it or it got corrupted. But I wanted to go through this finding the pH and finding the concentration of hydroxide or hydronium atoms in a solution. And up here you'll have some of the notes associated with it. And I'm going to try and go through them so they make sense. So we're going to go from the top here. Now, most of the time, if we're dealing with whole numbers, finding the concentration is very easy. But if we are given a pH that has a decimal, this formula reduces the math that we learned in class and into just one calculation. And that way we won't screw it up when we're trying to go through the math on our own. So let's get this nice blue color here. So let's say we are given a pH. I know that the P is supposed to be smaller. Let's make it big. The pH, let's say is, let's just pick a number. So 2.6. Right? We would take that pH and plug it in to follow the formula up above. 10 to the negative 2.6 will then be our concentration. So let's plug that in. So 10 to the negative 2.6 is 0.00251 and some others. Now we have two significant figures here, and so we're going to carry this. To write this in scientific notation, we've got to carry that decimal over. So that's 1, 2, 3. Let's remember that, 3. So that's 2.5 is it, we'll round down, times 10 to the negative 3 is the concentration of a solution that is, a pH of 2.6. Now let's choose a different number here. Let's do a different color too. Pink, sure. Let's have fun with it. So let's say we're given a pH of. Sorry, I don't know how to write for heaven's sakes. Well, let's say we're given one that's on the opposite side of the scale. Let's do 8.7. So we're going to plug that in to the 10 to the 10 to the negative this number here. So 8.7, and that's going to spit out a much smaller number. So 10 to the negative 8.7. It's going to spit out a very small number. Now, the higher the pH, the more this is going to drag across the screen. So I got 0. See, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, and 8 zeros and a lone 2. Okay, so then we have to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be 2.0 times 10. And I'm so sorry, it's freaking 2 a.m. 1, 2, 3, 4, 5, 6, 7, 8, 9 to the negative 9. That is the concentration. Okay? Now, just for funsies, let's do one additional one, and let's do this galaxy one. Sure, let's have some fun with this. So let's say our pH is something really big. Let's say 13. So we are given a pH of 13, let's say 0.5. 13.4. We're going to spit that out into our 10 to the negative 13.4 equals 10 to the negative 13.4. Now my calculators finally spit out something for me that's already in scientific notation because there's so many zeros. And so I got 3.9810 times 10 to the negative 14. Now we only have 3 significant figures, so we need to just show those 3. So that's 3.98 times 10 to the negative 14. Boom. That is the answer. So hopefully that makes things a lot simpler as far as figuring out those concentrations. It reduces the math that's needed, and by reducing the math, you make less mistakes. And this works with any pH. Okay? So let's grab this and let's just delete all of our math here, and then we'll go to the next step. I'm sure there's probably an easier way to do this, but we're just learning, we're having fun. Okay. So we're just going to delete that. Okay, so now if we are given a concentration of specifically, make this a little bit more specifically, right? If the concentration is hydronium and we are being asked to figure out what the pH is, this equation right here, the negative log of that concentration, is the pH. And it will work again every time. So let's do that blue again, that's nice. So let's say we're given 2.9 times 10 to the negative 4. And this is concentration of hydronium. So then we're going to plug it into the negative log. Right, so we're going to take this whole thing, shove it into here, and then it will spit out our pH. So negative log, and that's important, negative log 2.9 times 10 to the negative 4. And I always do the closed bracket. I don't think it really matters, but I always do it. And so it spits out a 3.5376. We only have 2 significant figures, so we're going to be focused on these 3 right here. And we're going to round down because 3 is less than 5. So our pH equals 3.5. Easy breezy, right? Super simple, no complicated math. You're just plugging in the number that you're given and it will spit out the number that it is. Super easy. All right, so let's do one more, okay? We can do much more. I can make a test if we want to, drag this out and have it be more involved. But for the sake of this video, I'm just going to do 2 examples so that it's clear. So we are given a concentration of, say, 9.2, just to do the inverse of that random number. We'll do times 10 to the negative 11, sure. We're going to plug that in. Negative log of 9.2 times 10 to the negative 11. Don't forget that negative, right? Close that bracket, and it spits out, sorry, a little slow on my notes. That's going to spit out 10.0362 and some extras. But we only have two significant figures, so that would be just 10 is our pH. Okay, and if I'm wrong, I might be wrong on the significant figures because that might be a placeholder or whatever. If I'm wrong, then it'd be 10.0, and then that would be correct. But I don't think it is, so we can just 10 is the pH. So now let's go through this next one, because I think this next part is going to be more common on our exam, which is very upsetting because I don't think we covered it very much in our practice in class. That's okay. We're here to do some learning. Okay? So, this note is a little bit confusing. I apologize. I should have cleaned this up before recording this video. But we are trying to find the hydroxide atom here. You want to find that. And so we are given a pH. So in a given pH, let's say it's 7.6. What will happen in order to find this number using the least amount of math steps, increasing our ability to get a right answer, we're going to take the kW, essentially, is 1 times 10 to the negative 14. That number's key, so that's where that 14 comes from in this. So we're going to do 14 minus, and it has to be in this order, 7.6. Now, as you can see, it's late, I'm tired, I'm never going to trust myself to just do that in my brain. 14 minus 7.6 is 6.4. Then we can just simply plug that bad boy into this original equation that we were trying to figure out. So do 10 to the negative 6.4 will then equal our concentration of hydroxide. Because by doing this 14 minus that number, it gives us the hydroxide pH, if you will, the basicity of the solution. And so we'll go into that, we'll do 10 to the negative 6.4, and it's going to spit out a big long row of zeros. So I'm going to count them first. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then 3, 9, 8. Now we only have two significant figures. So what we're going to do is we are going to do that. We'll round that up, which will round that up. So it would be 4.0 times 10. And let's count what negative power it's going to be. So 1, 2, 3, 4, 5, 6, 7. Negative 7. And that is the concentration of OH, or hydroxide atoms in the solution. Does that make sense? So let's do it one more time and I'll walk through a little bit differently, or talk about it differently. So we are given a pH let's say 13.2. Okay. In order to find the hydroxide number, we're going to do 14 minus 13.2. 14 minus 13.2. That was a goop. 14 minus 13.2. There it is. So it's going to be 0.8. Okay. So we're going to plug this bad boy into that equation, which is 10 to the negative 0.8. 10 to the negative 0.8. Which equals 0.1584, so on. And so what this looks like, since we got to just move this decimal just one, the concentration of OH negative or hydroxide atoms is 1.5, and since we're rounding up, right, I'm actually wrong here, it's 1.6 times 10 to the negative 1. There you go. So hopefully that makes a lot of sense. There's another note that I've scratched off in this white area. I'm still working through a lot of that to see if there's additional questions that might be curveball-y. I'm happy to make a test for you guys if that's helpful. I'm going to be in class, or I'm going to study after class on Wednesday, right after class, and right after class on Thursday. If you have questions, stop by, message me on Teams. I am very responsive, and if we need to collaborate outside of those normal study hours that you guys typically do, I'm happy to do that for you, or just do a one-off if people need to just workshop this. I don't know everything. I don't profess to know everything, but I have a really good tutor, and it's been going very well. And so I wanted to pass on some of these nuggets of clarity where we're not doing just tremendous amounts of math that are likely to fail. Hope you guys are doing great. Let me know, and I'm happy to help.